Okay, so now we're going to work on the second IB question. So I realized after recording quite a few videos that my microphone didn't sound the greatest, so I tried to fix it, so I hope this is a decent upgrade. But getting into our second question that's also numbered 7, it says, let me just read it carefully here. Consider the functions f and g divided by f of x is equal to 2 to the power of 1 over x, and g of x is equal to 4 minus 2 to the power of 1 over x, where x cannot be equal to 0. And then it says, find the coordinates of P, the point of intersection of the graphs of f and g. So for A, just nice and straightforward, finding a POI, so equating the two equations and solving for our x and y values. So I've got 2 to the power of 1 over x is equal to 4 minus 2 to the power of 1 over x. So, over x. Moving the 2 over to the other side. So the term over here I have 2 to the 1 over x plus 2 to the 1 over x is equal to 4, right? And now I have 2 of the same thing, right? So it's like having x plus x. I can rewrite this instead of with addition as something multiplied by itself. Or sorry, not multiplied by itself, added to itself. So 2 times my original item. So I can rewrite this as 2 times 2 to the 1 over x. Okay? And I'm going to write 4 as 2 to the power of 2, right? Because I'm trying to get the bases to line up. Because now that I have this as 2 times 1 over x, I can write this as 2 to the power of 1. So this becomes 2 to the power of 1 over x plus 1, right? Because we're adding our exponents together, is equal to 2 to the power of 2. And now because the bases are equivalent, I can equate the, I can equate the exponents. So it becomes 1 over x plus 1 is equal to 2. Moving the 1 over to the other side. So this should be an equal sign. So it becomes 1 over x is equal to 2 minus 1. So 1 over x is equal to 1. Cross multiplying, I get x is equal to 1. Making my life as easy as humanly possible, plugging it into the more simple equation. So I'm just going to plug it into f of x to find my y value. F of 1 is just equal to 2 to the power of 1 over 1, which is equal to 2. Therefore, P, our two coordinates, our x coordinate is 1, our y coordinate is 2. And we're all done part A. So now let's get into part B, because it's going to seem tricky at first, but it actually works out pretty nice. So part B is asking us to find the equation of the tangent at our point over here, P. So first I hear the word equation of a tangent, I know I need to find the derivative of f of x. But I'm going to rewrite f of x as it was given to me in the question, but I'm also going to rewrite it again to make it algebraically simpler to solve. Because for now, I'm just going to look at my base. I'm going to rewrite my base. Because if we recall, 2 can be written as e to the ln of 2, right? Because essentially the e and the ln cancel each other out, and I would be left with 2 anyway. So that's my first algebraic manipulation. And the reason I'm doing this is because I want to rewrite my parent function as e to the power of something, because I mean, it's really easy to differentiate e to the power of anything, right? Because it just becomes itself multiplied by the derivative of the exponent. So what I'm going to do is rewrite f of x. I haven't even derived yet, or differentiated. So it becomes e to the ln of 2, everything to the power of 1 over x. And now because I have a power of a power, I just do multiplication here. So it becomes e ln of 2 times 1 over x. Okay? So we're getting close. Now, the second algebraic manipulation, so I guess this will be, I'll circle this and do like a little 1, my first algebraic manipulation. My second algebraic manipulation is let ln of 2 times 1 over x be equal to g of x. This is one of those optional steps where I'm just replacing it with a second variable, so my my algebra looks cleaner. So it's not absolutely mandatory. Basically, now f of x is really just e to the power of g of x. And now I can finally differentiate. So f of x, or sorry, f prime of x, not just f of x, I misspoke there, is equal to itself, right? E g of x, but multiplied by the derivative of g of x, right? And then this is nothing new. I'm literally just rewriting what I started with. The only thing I actually have to contend with is finding the derivative of g of x. So let's do that on the side, and I'll count that as our third algebraic manipulation, I suppose, is g prime of x is equal to, what do we have here? If g of x is ln 2 times 1 over x, then that's what I need to differentiate. I have ln of 2 times negative 1 times x to the power of minus 2, right? And that's really nice and straightforward. It doesn't really require an elaborate explanation. So then, combining all these together, this ends up going in the denominator, but with a positive exponent, and then I just have minus in front and ln of 2 over here. And now I can put all my ingredients back together. So f prime of x is equal to e to the g of x. E to, what do we say g of x is going to be? Ln of 2 times 1 over x, multiplied by negative ln 2 over x squared. And now we're going to basically perform the same algebraic manipulation we did in step 1, just in reverse, so we can get rid of this e and this ln of 2, not just ln on its own. So this becomes, what do we have here? 2 to the 1 over x multiplied by the negative ln of 2 over x squared. X squared. And now that I've got my actual equation, I can substitute my value, because remember, I'm looking for the tangent at the point P. So f prime of 1 instead of x, this becomes 2 to the power of, well, 1, so it just becomes 2, minus ln of 2, that's just a constant. It's a really ugly constant, but it's a constant, divided by 1, right? Because 1 squared is still just 1. So this finally simplifies to give me negative 2 ln 2. And this, all of this work was finding our slope. We just need to make our lives easy, because it says find the equation, not in a specific form, but I just found the slope, and from part A I have a point, so that's the exact thing I'm going to do. Put it into point slope form, so I end up with y minus 2 is equal to negative 2 ln 2 multiplied by x minus 1. Whew. And that's our final answer. Okay, so I hope that made sense. I tried to be as clear as I could with the algebraic manipulations that I used. Again, like I said for the previous question, if there's anything you didn't understand, I'm happy to answer it on Thursday when we see each other again. Okay, so that was the second IB question. Give the third one a try, and then open up the next video for the solution.